my talk today, it's about using simple database triggers to solve complex Django problems. And a great problem was hinted at just now is that, oftentimes we will use the ORM in Django. And, that's great. And the ORM is incredibly flexible and you can do so many things with it. But there are a lot of things that can be done with database triggers for a lot of application level problems. And I'm going to try to go into, what this means in practice and how you can actually use database triggers inside of your Django application to solve a lot of really complex things. And just a little bit about me really quickly. I'm leading the engineering of a new insurance startup. We're going to be making supplementary insurance products. And most of the code here is from my time at Jive. And I just want to give a special thanks to Sam, Bobby, and Tomas for their support, because a lot of the stuff you're going to see is work that I open sourced when I was at Jive. So really appreciative of that. And so just to start off, a lot of you all have probably encountered some of these problems in practice. And I would guess that many of you all will also encounter these problems as you develop more and more Django applications. And some example problems I just want to go over really quickly, and this will kind of illustrate the introduction of like database triggers. Like one great example is, how do I track all changes to a model? Or how do I soft delete a model? Like make sure that I don't delete the model, but instead maybe set a flag on the model. How can I make an append-only model? How can I make my fields read-only? Or how can I keep a field in sync with one another? Another interesting problem that I've encountered in a lot of organizations is, how can I make sure that engineers create or update models with the exact same interface? Like, how can I make sure that someone doesn't call .objects.create when I really want them to call my fancy custom ORM method that I made myself and that I really wanted them to use as the official way of updating that model? So these are a class of problems I like to refer to as database level problems. And what I mean by that is that these problems can be much more elegantly solved in the database level rather than trying to write code in the application to solve them. So, oftentimes these database level problems are often solved at the application level. So that history tracking example I just mentioned, there's this whole grid of Django apps that you can search for online that will do history tracking. And, a lot of times they're going to be implemented with Django signals, or some of these apps will have base models or query sets that you override, or potentially you'll have to override your model's save method. Now, when it comes to problems like these, making sure you don't do something on a model, tracking changes to a model, a lot of times when you solve them in the application layer, they're going to be very easy to bypass, or like unexpected things might happen. Like, for example, Django signals are not going to actually fire if you do a bulk update on a model. So that's like one example where you're going to have to account for that if you're going to try to do this stuff in the application. So basically the whole point of this talk is that in many cases, solving database level problems in Python can end up actually being a very fickle and complex thing. And it can lead to a lot of database integrity issues down the road when you're just trying to make sure that your tables and everything are the way you want them to be. So basically what I'm going to talk about today is using database triggers for database level problems. So a database trigger, it can solve a lot of database level problems more succinctly and much more reliably than you can with like Python code in your Django application. So what exactly is a database trigger? I've been mentioning this a lot, and a database trigger is a routine that runs in the database, and you can configure it so that it will be executed based on a certain database event or based on a certain condition in that database event. So some really broad examples of what triggers you can configure. You can configure a trigger to execute after an update of a row before you delete a row. You can create a trigger that will fire before a row is updated whenever certain fields of the row match a certain pattern. So these are some very broad examples, but this kind of gives you an idea of like what triggers are. And although triggers are available in MySQL and other databases, as mentioned earlier, we're going to be covering Postgres triggers today, specifically row-level triggers. However, if you don't use Postgres in your application, a lot of this talk will still be applicable to you. So the anatomy of a trigger, what does this look like? So as I mentioned, a trigger is a SQL thing. It's something that runs in the database. So we actually have to create it using a SQL statement. And this is kind of like what the SQL statement looks like. This is actually pulled from the Postgres docs. And basically you have to define, when is your trigger going to run? Is it going to run before or after a specific event, in this case, an update, an insert, a create? And then we're going to configure what table that this trigger is going to fire on. So making a trigger that fires before the update of a specific table. And when I say table, I really mean like a Django model, because each Django model corresponds to a table in your database. So some more sophisticated options of a trigger. You can configure a trigger to fire for every row in an operation, or configure it to fire once per statement. So what I mean by this is, imagine if you update 10 rows at once. Your trigger, if it's a row level trigger, it will fire 10 times, one per each row in that update. If you configure a statement level trigger, it will run once for that update. One of the coolest things about triggers is that you can configure them to run based on certain conditions in the database. So this is one of the really powerful ways that you can use triggers to do a lot of complex things in your application. So you can configure a trigger to run when something in the old row changes to something in the new row, for example. Then, of course, when all this configuration is done, you're going to have to make your trigger fire a function. And when I say function, I don't actually mean a Python function. I actually mean a database function. So Postgres allows you to define functions in the database that run code that is written in this language called pgSQL. And this language looks a lot like normal SQL. And just to elaborate a little bit more on some very important properties of triggers. So when we're talking about row level triggers, one of the big properties of them is that you can access the old and the new row in the function of the trigger and the condition. So if you're updating one of your models in Django, for example, and you're updating one field, to a different value, inside of your trigger, you're going to have a full copy of the old row and a full copy of the new row. And so this is really great in your triggers, because you can audit all the changes that are happening, and you can do a lot of really interesting things just by having access to the old and the new copy. One other kind of really important row level trigger property is that the row can actually be modified in place inside of the trigger itself before the database then performs the operation. So you have the ability to take the new row that's about to be updated, and you can change it in place however you want to, and then that's the row that's going to be used whenever Postgres does the update or the create. Kind of a third really cool property of row level triggers is that you can actually configure a trigger that returns null. And so what this does is it actually ignores the entire database operation. So for example, we can ignore a deletion ever happening. And what that means is that if your Django application tries to delete a model, it will think that it deleted it, but inside of the database, the operation was actually just ignored entirely. And although this might seem like a really weird thing to do, it actually has a lot of really interesting use cases in practice, some of which I'll go through. Now, I've kind of known about triggers for a while at a high level, and what they can accomplish, but the main thing that's kept me from actually using them with Django is just that the integration can be very ugly. You end up having to write a bunch of raw SQL. You have to write this function that I mentioned. You have to write a create trigger statement, and then you have to try to integrate that with your migrations and make sure that they're installed. And on top of that too, I mean, the worst part about this is that you have to find a way to organize this into your code base so that people kind of know when I'm working with this model in the code base, what kinds of stuff is going to happen behind the scenes. So these are the things that have prevented me from wanting to use like triggers in practice with Django. It's just difficult. And this is where django-pgtrigger comes into play. So I will post these links in the chat afterwards so that you all have all these links. You don't have to copy them down right now, but django-pgtrigger, it's an open source app. If you go to that repo, it has a ton of documentation, has a ton of tutorial examples, and it's pip installable. And the main purpose of this library is that it allows you to configure triggers alongside your Django models in a very Django-like way. So triggers are automatically going to be installed for you whenever you migrate your models. And even though you can write raw SQL in these triggers if that's what your application calls for, django-pgtrigger provides a lot of default triggers out of the box that handle a lot of common scenarios. So the whole goal of this, again, is that you can just write Python code, you can write it in a Django-like way, and that you don't have. And just quick overview, whenever you install pgtrigger in your app, you register the trigger for your model using this register decorator, and you provide this decorator with all the triggers that you want to register for a model. And every single trigger inside of pgtrigger, it has the following core properties. And these core properties relate very closely to those core things that I showed in the SQL statement earlier. So each trigger has an operation. Do I care about inserts, deletes, updates? Each trigger has a when it should be executed. Triggers have conditions. So you can make a condition for your trigger. And again, a condition is just a where clause in SQL. And pgtrigger comes with a Q and an F object, very similar to Django's Q and F objects that allow you to write conditions against the old and the new rows. And we're going to go into examples of this in a little bit, so you can see like what this looks like in a real scenario. The final property that triggers have is a function. This is just the raw SQL that the triggers execute. Again, the purpose of Django pgtrigger is that you don't have to do this. But if you want to do this, you want to write like a very complex trigger, you totally can with Django pgtrigger. Again, but before I go into all this too, just remember you can ask whatever questions you want in the Q&A, and you all can upvote them after the talk is over, and I'll go over those questions and answers. For this talk, I actually wrote a whole tutorial for this, and this is in a separate repo called Django pgtrigger tutorial. And again, I'll post this link in the chat, but you can go to this tutorial and you can set it all up on your machine, and you can run all these examples I'm about to run. And these examples run against a Postgres database and an actual Django application with triggers defined. So I hope this will be helpful for anyone that wants to maybe see how this works. And hopefully it'll be easy to set up and run for people. So the main thing I'm going to talk about from Django pgtrigger, and this is like the core thing that I use a lot in practice, and it's protecting model operations. So Django pgtrigger comes with a trigger called the protect trigger. And I'm actually referencing the tutorial here that I just linked. But the Django pgprotect trigger allows you to protect operations against a model. So if we look at this example here that I'm highlighting, we have a model here. It's called the cannot delete model, and this model cannot be deleted. So what we've done here is we've registered a trigger with pgtrigger, and it's a protect trigger. It's a special derived trigger that's part of the library. And what we're doing is we're protecting against the deletion operation. So anytime someone tries to delete this model, it's going to throw an exception. So as you can see here in this code example, I'm going to make a cannot delete model, and I'm going to try to delete it. I'll actually run this code example for you so you can see what it does. It's going to raise a really ugly exception. And this exception is actually thrown from the Postgres database. The Postgres database throws an exception, and it bubbles all the way up to the Django application, because Postgres itself is what is protecting this row from being deleted. So again, with just a few lines of code, you can protect your model from deletes. You don't have to override your delete methods. You don't have to override query sets. And you can have the confidence in knowing that anything that tries to delete this model will not be able to delete it. Kind of continuing with examples of this protect trigger, you can use a protect trigger to make an append-only model. So what do I mean by append-only? I mean a model that you can only delete or update. So here we've defined a protection trigger, and we're going to protect against the update operation or the delete operation, which means that now we have a model that can only be created, which is also just called an append-only model. So in this code example here, we create the append-only model, but you'll see that anytime we try to save it, or anytime we try to delete it, it just results in an error. So we'll see some print statements from this code example. This model cannot be updated, it cannot be deleted. I've gone over a few examples of triggers that run on a table level. So I protected this table from being updated or deleted, but you might be wondering, how could I protect a column from being updated? So this is an example of how you can make a read-only field using Django pgtrigger. So again, we can use the pgtrigger protect trigger for this example as well. And in this code example, I have a read-only field model. And this created at field here is the field that I'm going to protect from any sort of updates. This is a read-only field. I want to make sure that it's just, set whenever the model is created, and that nobody ever touches it. However, this end field here, I've set up this model so that it can still be updated. And the way that I've done that, again, I made a protect trigger against the update operation, but the key thing here is that I've added a condition to this trigger. So I've set this up so that this trigger only executes whenever this condition holds true. So this condition means that this trigger will only fire when the old rows created at variable is distinct from the new rows created at variable. So anytime the created at changes from the old row to the new row, this protection trigger fires on an update. So what that means, again, is that we can make one of these models, we can update the end field, we can do all that, but the moment that we want to try to update this protected field here, we're going to be met with an error. So this means we have a read-only field. Now, if we wanted to make the end field and the create edit field both read-only, we can extend this condition just a little bit more, and we can add an or here, and we can make it so that we're protecting against created at and the end field. So again, this is very similar to the Django's queue object. For those that have used it, you can OR them together. The nice thing about the pgtrigger queue object is that you can write conditions on the old and the new row being updated that's part of the trigger. So we've gone over a lot of examples of how to protect certain things. I want to go over a really cool example that I like to use in practice, the soft delete pattern. Soft deleting is when you don't actually delete a model, but you instead set a field to a certain value. So in this case, my soft delete model has an active field, and I want to make sure that whenever this thing is deleted, it actually sets the active field to false. And this is what the pgsoftdelete trigger is used for. So whenever we configure this trigger, we can create a soft delete model. We can delete it in our Django application, and Django actually thinks that it deleted it. But underneath the hood, Postgres is actually just setting the isActive field to false. So whenever we grab this, we can grab this model again, and we can print off the isActive field, and it's actually false. So again, this is just another example. There's many Django apps out there that make soft delete models, but you have to override query sets, you have to override managers, and you just have to hope and pray that everyone at your company uses those managers correctly. A Postgres trigger, however, you can implement it in one line of code, and you can be assured that this model will never actually be deleted. It will only be soft deleted whenever people interact with it. I'm running into some time constraints. I only have 2 minutes left here, so I'm actually going to bypass this example, but this next example was an example of how you can version a model. So you can actually set up some triggers to automatically increment a version if you want on the model. I'm just going to skip over that really quick though, because I have two really cool examples that I wanted to be sure I went over. One example is creating an official interface with a trigger. So what do I mean by an official interface? I mean making sure that engineers at a company use a particular interface to do a particular operation. So in this example here, I've created a model, and I've actually protected this model from ever being created. And what I've done instead is I've made a custom model manager, and I've made an official interface that ignores this insertion protection, meaning that you have to use this interface here if you want to insert this model. So what does that look like? Well, if we make the official interface object here, we can't actually do it with .create because that's protected. However, if we use our official interface here, the object can be created because, again, we've used this thing called pgtrigger_ignore to dynamically ignore this trigger only for this bit of code. So this is just kind of like one interesting way of using triggers where you can combine your application with the database. There's one example I'll just quickly go over it, restricting fields at transition. So let's say you have a field called status on your model, and status actually transitions among all these different states. Let's say that you want to say that these are the only transitions that are valid for that status. Well, you can use the pgtrigger FSM trigger, the finite state machine trigger, to make sure that only these transitions can happen. So this is just a quick code example of what that looks like. I wanted to be sure that I could go over this one final example because this is really one of the best problems I've I've solved in practice using triggers, and that's tracking model history and changes. So I alluded to this earlier, but you can search online for model auditing and change apps. You're going to find a whole grid of Django apps that do this. And we've actually made another app called Django pghistory that's built on top of Django pgtrigger that is specifically made for tracking model changes. And this just gives an example of how you can configure it, but basically it's very similar to pgtrigger. You can set up pghistory so that it tracks snapshots of your model and can track specific events that happen on your model. So really cool thing about this, you can set up pghistory for your app. It's going to be using pgtriggers. It's automatically going to make history models for you, and it's automatically going to track all the history of your models. So any changes you make to your model, even if you want to attach context to these changes from your application, can be done with pgtrigger. And then you can print off all these changes in your application, and you can visualize the history of your model changes. So again, this is a whole different library in itself, and has its own set of documentation. But I've just used it for so many things in practice that I thought I would note that this is another really cool example of how you can use triggers. So this shows like the char field going from hello to hi, the int field going from 1 to 0 in this operation. You can render some really cool stuff out of the box. Again, with triggers, you configure a very small thing and you get a lot of stuff out of the box that is relatively hard to do in software code. Again, the main takeaways of this, triggers can save an enormous amount of complexity in a code base, and they can solve a certain class of problems way more reliably than you can just in straight Python, but also a lot more elegantly in a lot of cases. So Django pgtrigger is a library that can help you integrate triggers into your project in a clean and idiomatic way. And I hope that a lot of people here might now kind of see some of the ways that triggers can be used in practice and might think about using them in their applications instead of trying to solve them in Python.